Hi everybody, my name is Henrik Vinge Karlson and I'm the presenter of the abstract guidelines for designing sand nourishments on low to high exposure coasts. The subtitle today is Building with Nature on the varying Danish coastlines. Um, this abstract has been made as a part of the Building with Nature project, which is an Interact 5 project, where, as you can see from the image here, includes a lot of different countries and a lot of different areas, coastal areas and also rivers. In this presentation, I'll be focusing on the Danish reports and also the Danish analysis. But in the guidelines, we have naturally included results from our partners and our own results. The objective of Building with Nature is to increase the evidence base on the use of Building with Nature methods. And for us, it has also been a goal to produce guidelines on how to approach and incorporate Building with Nature solutions on the Danish coastlines. And here we focus mainly on nourishments. So before we talk about the guidelines, I want to set a setting, so to speak. The framework has been to work with a source pathway receptor model, where we work, as you can see in the imagery here, actually a pretty good example where we have the waves coming from the right side, and we have the high water, low water, we have the currents, which are the sources, and then we have a pathway, which is the seabed, the beach, the dunes, and then we have the receptor area, which is in the hinterland of the dunes, where we see vacation homes, city, infrastructure, agriculture, protected nature. So here we work with the pathway and how to modify it in order to increase potential safety in the dunes, for example. This presentation will revolve around the guidelines we've been working on for nourishment on the Danish coastlines, and this conceptual model presents the structure for the guidelines and also actually how we're going to move on for the next 10 minutes of this presentation. So we start out with a challenge or the problem where we, for example, could have flooding or erosion. This is then acknowledged and we say we have a problem and then we need to maybe solve it or actually get something implemented in order to get this handled. We then move on to analyzing the system and gaining a system knowledge on what type of coastline or what type of nature we're working with. This baseline or this knowledge then gives us the possibility to move on and say what objectives are we then setting to actually challenge or to approach the problem, and what methods are then possible to use and how do we design it, and does that again fit into the system. So this is one iterative process in itself. And from this we move on to say, okay, we have now the methods and the design and the objectives that we actually want to meet. And in order to monitor or actually follow the development of the methods, we then establish or recommend to establish a monitoring program where you can use different sort of monitoring methods in order to follow how the development of the area or the method actually takes place. And then, of course, there's a monitoring period from establishment, monitoring, and then to the analysis part. There might be some storms passing, or there might be some seasonal changes depending on the lifetime for the specific method or design we've implemented. This leads to the analysis of data and the development of the coastal stretch. How has the Building with Nature method then developed, and are the objectives achieved? So, for example, with the nourishment, you can say, no, you have possibly a storm impact which have eroded a lot of sediment downstream or across the profile, and then we need to reconsider the method and design, or possibly also how it's done, and then again iterate to the challenge. Or if yes, we still need to reassess it and also to re-nourish possibly in the future, which leads again back to the system understanding. And I'm going to say system understanding a lot of time through this presentation because it is so basic to actually have this system understanding for the rest of it to actually work. So the challenges are multivariate across the Danish coastlines. We have flooding areas, we have erosion areas, and we have different storm impacts depending on where we look. The red dots on the screen represents areas where we have made analysis on both aeolian dynamic but also on nourishment campaigns. And we have one dot for the quick viewer who can see is actually in Sweden for Ystad, which is also incorporated for these guidelines. And naturally also include results from our partners around the Building with Nature project. Again, we move to the area of Krogen. You have already seen this image once before, but it's actually a pretty good illustration on how the sources or the water and the waves and the storm impacts are both creating an erosive problem, but also a flooding potential for this area. This represents an area where we actually have been nourishing on the beach, and we've also been analyzing it for aeolian dynamics across and along the dune, which is necessary for the buildup of the dune, and then also again to counteract the erosion of the dunes, and also to increase the safety of the dunes in order to avoid flooding of the hinterland, which also includes a larger city. So this is one of our pilot areas and also one of the multivariate challenges that we see. So system-based decision-making is something that we stress in these guidelines. You have already seen this iterative process once before. The system-based knowledge and the natural dynamics and coastal characteristics are needed in order to understand how we actually can implement different things. The objectives must then be set for what gives a good purpose both to the challenge but also to the system, and then the methods must be chosen to meet the objectives and designed in order to fit the system again. We're trying, so to speak, in Building with Nature methods on nourishments to work with the system dynamics rather than against it, because we know that sediment is, when we nourish, going to be moved across and along shore, so we need to re-nourish at some point. But it's important to stress that sediment naturally doesn't just disappear, it is transported elsewhere. And this is something that is very, very needed to be stressed in these nourishment campaigns. The design process is also where we try to optimize for benefits both in protection and also for the nature, and potentially for recreational purposes. As I said before, working with dynamics are quite vital, and the system-based knowledge again is vital to actually set the objectives and also to implement methods. It's also a very, very important part of establishing a monitoring program. And why is this even necessary? This is naturally because if we don't monitor and if we don't follow the development of the Building with Nature methods or the nourishments, it's impossible to say whether or not they have actually increased the safety, or even if they've achieved the objectives that we set out. Monitoring across the different Danish shorelines, coastlines are difficult because the data availability to start out with is very different and very highly spatially differentiated across the country. On the west coast, we have a lot of measurements. On the inner Danish coastlines, not so much. And then again, it must also, when we implement or when we establish these monitoring programs, be considered what is necessary and what are we trying to analyze. So what is the objectives again, and what is the system doing? It's a matter of time scale, it's a matter of hydrodynamics, it's a matter of the resolution, what you need. And once we have these things established and also what scale we're working on, we can choose the methods that fits. Whether it's satellite imagery or whether it's profile measurements with GPS, or it's LiDAR measurements, manual observations, or imagery from drones, it doesn't, naturally it matters depending on what resolution you want and whether you want it qualitative or quantitative. But as long as you're monitoring, you're still doing a better job if you didn't. And that's what we're stressing in some of these smaller nourishment areas. And then of course there's the current, the wind, and the waves, and water levels. And as much as you can get, this better, but also a problem if you don't really use them in the analysis. So this must also be incorporated in the analysis part before, so we know what we're looking for, or at least have an idea of what the objectives are leading us to from a system-based knowledge. Here are some examples on how we can include different measurements, where we have interpolated model of profile measurements, and we also have a volume development for nourishment. So we can actually follow it from top to bottom on the right hand figure, how the nourishment diffuses into the profile after storm, and how the volume diffuses of nourishment over time on another stretch, which has then been fed to two models in order to get a better understanding on how to nourish next time. A low cost and very simple method is to use drone imagery. As here you can see how a nourishment has been implemented, and then how the finished product was. And then after the first storm, you see that some revetments are back again, and some groins have also popped up from under the sediments, and then after another storm. But we still see the process of developing nourishment, and this can also be used in some areas where the budget is not so high. So once we have this knowledge and we have these analysis, it's important to actually include them, and the results naturally also to include them in the future, and also to not just say the sediment moved from here to here, but also to use them when implementing new nourishments or renourishments are conducted. Here you see a stretch with a revetment protecting a road, which was nourished with a new beach section actually placed, as you can see on the right hand side, or the right imagery. After 1 year, the sediment processes meant that some sediment in the northern end again migrated south, which is not unexpected. But this gave some room to thought to maybe implement a different structure for the next nourishment. And this is how we are trying to propose it for the next time, to get a more exponential shape, incorporating the shape of the harbor with the nourishment, so the sediment allows for a long-shore transport and cross-shore transport to stay within the profile which we're nourishing for a longer period of time. That was all for me, and I think almost all my time is up. So thank you for listening. I have one last thing to present for you. Here you can see in the imagery on your right that we've moved sand from the left-hand side of the dune to the seaward side of the dune, and we've actually used different shapes along the beach and used different angles of approach for these nourishments to try to steer the sediment, aeolian sediment, into the dune where it's most needed. If you want to read more about the building with nature, the two links are below, and if you have any questions, you're more than welcome to set them to me. I hope you'll have a really good conference, and thank you for listening.